Alright, so in this video we're going to be focusing on how to get the values of different angles using cosine. So similar to the sine video, I've got on the right hand side cosine 0, 30, 60 and 90. Oh, I need an equal sign there, I missed that out. And I've also got my unit circle on the left hand side to kind of refer to. So let's get started. So we're going to see if we can set up our triangles the same way as we did for sine. So remember, theta is always kind of in that corner here on this side. So let's do cosine 0. So cosine 0, there's no angle like we discussed in sine. It's kind of like a straight line, right? So that's kind of what that triangle would look like. It wouldn't have any kind of angle of elevation at all. It would just wouldn't have an angle. The angle would be 0. So remember, for when we discussed sine, we said that sine theta is equal to b. If we recall back to one of the earlier videos, we found that cosine theta was equal to a, or our distance on the x-axis. So I'm going to keep note of that in our maroon color. I'm going to write that here. So this is equal to a, or cosine theta. Okay, so let's do it. So for cosine theta, so cosine 0, so based on that triangle, not really triangle, but based on the line that we've got at the moment, what is our distance from the origin to the point that we've got? So this is actually also known as 1, 0. So that means our cosine 0 is actually equal to 1. So that's a fun one. Let's go to our next one. So let's keep going. So we'll notice a pattern in a bit. So cosine 30. So cosine 30, we're going to see if we can make a triangle of 30. So remember, if this about halfway is about 45, let's do a little bit less. Let's do like something like that. I'm going to get rid of that other line. And let's see if we can figure it out. So that's 30. So if we use our blue, and we're going to see, just like my triangle here, I'm going to refer back to this point. So let's see if we can find out what this value is going to be. So if we said that this is about 0.5, 0.6, 0.7, 0.8, 0.9, it's about kind of halfway-ish. So we can say maybe that's 0.85. And when you put it into the calculator, you'll actually find that it's 0.86602544038. Does that look familiar to you? We'll get to that in a second. So let's keep note of that fact that that looks kind of familiar to us. All right, I'm going to erase it for now. Let's go back to the deal. So let's say this is meant to be 0.86. Okay. Or should be really at 87 if we rounded it. Let's round it. Let's be good. 87. So let's go to our next one. So cosine 60. So I'm going to create a new triangle now. So I'm going to get rid of all this stuff. I'm going to create cosine 60. So 60 is just a bit above 45. So maybe like that. Oops. I can't seem to align my stylus properly. Let's try that again. So let's say that's 60 there. Okay, so we're kind of using this straight line that we make to kind of create that triangle as our guide. So this point here is exactly where cosine 60 is going to equal. As you can see, it's kind of halfway in the middle. So that's like, oh, my line's not very good. So that's about halfway. So we can say it's 0.5, and would you, Lord and behold, you can see that in our calculator it's actually 0.5. Try it for yourself. Check it. It is actually 0.5. Okay, so I'm typing it in now. Yep, just double checking. It is there. So let's do our cosine 90. So we discussed earlier that cosine 90, or our 90-degree triangle, would actually end up being a straight line like that, if you remember. Okay, so this is our triangle. I put my quotation marks in there. It is our triangle. And we found that because of our measurement of sine, which is based on our y-axis, that was going to be 1. What's the distance of it on our x-axis though? Did it travel anywhere along here? No, it didn't. So it's because it's remained in the same spot, we're actually going to call it 0. That's a funny looking 0. Let's change that. All right. So like I said before, you'd notice that little pattern with that cosine 30, and it looked like a number that we'd seen before. So if I go up a little bit, you can see what we did previously. And look, we've got some of those numbers again. We kind of see it. So let's kind of fill in the blanks. So let's see our patterns here. Okay. Oops. let's see our patterns. So sine 0 is equal to 0, which is equivalent to cosine 90. I'm going to put it in red. Cosine 90. So we could say sine 0 is equal to cosine 90. Let's do our next one. Sine 30 is equal to 0.5, which is actually equal to cosine 60. So sine 30 is equal to cosine 60. Okay, let's do our next one. So our sine 60, which was that really long number that we had before, is equal to cosine 30. So let's write that down. Sine 60 is equal to cosine 30. And let's do our last one. Sine 90 is equal to 1, which is equivalent to our very first one that we did, which was cosine 0. So sine 90 is equal to cosine 0. So this is a lovely summary that we've got here of what we've learned over the past few videos. We've learned about how to set up our unit circle. We've learned that sine theta is equal to b. We learned that cosine theta is equal to a, or our length on our x-axis, and we've also learned how to determine different values using the unit circle for the angles of 0, 30, 60, and 90. So that's really, really useful. And the next bit I want to do, the last part, I know it's quite a few parts, but this is the last part, is kind of looking at what do you do when you've got angles larger than 90 and less than 180. So if you're interested in that, stay tuned for the next video and that'll clarify a few things. Thanks, guys.